makes ash and lava spew. Bullets can get thrown through the air. Back to starting instead. It's not gonna wait. It's gonna get to that balanced state. It's not equilibrium. Pressure starts building up again. It's like when volcanoes blow. For science classes, volcanoes forces on magma and gases. Underground pressure gets too high. Volcano blows up in the sky. What's it like when volcanoes blow? It's something you ought to know. Pressure builds without interruption. And then explodes in a volcanic eruption.
Go.
Dude, where should we build our Legos, man?
Maybe we can build a volcano.
Sure, dude. Let's make that happen.
Alright, yeah. Together.
These red ones, man. It's important.
Hey guys, what are you guys doing?
Trying to build a volcano.
A volcano? Well, that doesn't look anything like a volcano. What's this? What's that supposed to be?
Tried.
Thanks, bro. So nice.
A volcano's not square, guys. A volcano comes in 3 different shapes. There's a composite, a cinder cone, and a shield.
Really?
Yes.
Tell me more.
Well, actually, instead of telling you, I'd rather show you guys. I always carry this around with me because, as you know, I'm a volcano freak. I love volcanoes. This is a composite volcano, guys.
Wow, that's impressive.
See, as you can tell, it's not like a square. But we can get to that later. Volcanoes have multiple different parts of them. But this is an example of a composite volcano. Every volcano, guys, starts from the core, which is going to be where the magma chamber starts from, guys.
Oh, I have a question.
Yeah.
What's magma?
Magma is molten rock. So when you melt rock and other like iron and other materials, you get magma or lava.
So let me get this straight. The magma comes out of the volcano. Turns into lava.
Yes.
Okay.
Okay. All right. So tell us about this diagram. This is really interesting.
As you can tell, guys, every volcano has to start from some source, like everything in life. Well, the starting block for a volcano is the magma core. Magma core is melted rock and sediments, which is created by all the friction and the weight of the earth in the Earth's core. The next step it goes to would be the conduit pipe, which is the pipe in which the magma would travel up to get to the Earth's surface. Eventually, throughout some volcanoes, you can get branching pipes. Branching pipes are just paths or tunnels in a volcano that don't quite reach through the surface.
It's like cracks in concrete.
Yeah, exactly, like cracks.
Okay. All right. Whoa, what's this thing going on here? Is this like a mini volcano on the side here? What is that?
Yeah. Actually, that started off as a branching pipe, but as you can tell, it went through the surface, which they call a dike. It's a secondary path. It's a secondary path right off of the conduit pipe that reaches to the surface that will eventually create the parasitic cone, which is basically you can call it like a second entrance out of a volcano. This entrance is created by the side vent, which on this one you kind of occasionally, if you ever look at like Hawaiian volcanoes when they erupt or something, you see how like the main explosion on like 20-30 feet down the side, you see a little tiny puddle coming out.
Yeah, a little puddle.
That's the parasitic cone.
Okay. Whoa, that's not like throats we have, is it? Like, what's the deal with this thing?
Well, in a way it is. In a way it is kind of like a throat for a human being. That's the throat of the volcano. Like if you think about it, instead of going down, like for us when we swallow, think of it as the opposite. The volcano is going up the throat to get to the surface of the volcano and the earth. In the throat is where all the magma will eventually get up to. So as it builds pressure, volcano magma will move up the throat until it gets to the summit, which is the top of the volcano. At this point, when it gets to the top of the volcano, that's when the volcano erupts. Once the volcano erupts, it comes outside of the crater, which it will then go down to the, if it's a weak explosion, it would just flow off to the side, which would create the lava flow.
Oh, it's a strong volcano explosion.
That, if it's strong exposing, guys, I'm telling you, you don't want to be near it.
Could it affect like people's homes?
Oh, definitely. Anything. It doesn't matter if you're in a bunker, skyscraper. If you're nearby, you want to be away. One, it can throw craters and boulders up in the atmosphere and throw it across like miles away. It makes this volcanic ash, which is very, very bad for you, even to breathe. Like you get all rock and like basically when you breathe it in, it starts to harden. It's like breathing in concrete. It's very, very, very nasty. Well, the temperature of lava when it comes out is really hot. Like not like the hot days of summer where you start sweating. It's like at 90 degrees. Imagine something around like 1,000, 1,500 degrees. It's really hot. So anything in its way. Trees, even animals. It doesn't care who or what you are. It will literally burn right through you.
How does that affect the landscape? Like, does that does the islands get bigger? Like, how does that work?
Yeah, like Hawaii.
Yeah.
What happens is when the lava comes out of the volcano, it does eventually cool down. When it does, unfortunately, it does destroy anything in its path: trees, vegetation, homes. But when it does cool off, it's like a new canvas. It's black. It's very, very hard, but it's extremely rich in nutrition because all the animals or plants and wildlife that it went over is basically mixed inside of that. So it's very, very nutritious soil. So it's like restarting it all over again. It takes a couple of years, but it's very rich, but very deadly.
So let me get this straight. You're telling me that someday Hawaii is going to be huge if they keep those volcanoes there keep erupting.
Eventually, unfortunately, Hawaii won't be huge. It would be a little bit bigger, but unfortunately, the volcano of Hawaii is on a hot spot, which is a completely different cycle. That hot spot moves. That's why you have multiple islands of Hawaii. It's because that one hot spot is constantly moving. So eventually, Hawaii will stop growing in size and just be to its maximum point.
Okay.
When? It's kind of hard to tell because it's all based on plate tectonics, which help create volcanoes.
Okay, all right. Well, do you have anything more to talk to us about this diagram?
Not on this diagram. Like this diagram is, like I said, this is just showing one of 3 multiple types of volcanoes. This, once again, is a composite. It's have multiple layers. This type of volcano would be found more along on like the continental areas, like Mount St. Helens, or any like major volcanoes we can think of that's on a continent.
Okay.
Another type would be the cinder cone, like be kind of like this, but instead of being nice and round, be more of a point like a cone.
Okay.
That's because it's more of like a mountain type. The other type, which is a shield volcano, which is like Hawaii, that actually be a little bit less of an arc. Like if you think about it, like when you take a shield from like
Captain America.
yeah, like Captain America, and you put it upside down. How is that nice, flat, even layer? That's a shield volcano. Those volcanoes hardly ever erupt where it ejects big boulders into the atmosphere. Instead, those ones just give a nice little lava flow where it's nice and easy. It's still dangerous, but it's not going to erupt and throw a boulder into your house.
Well, let's hope not. Okay, cool.
But speaking of which, if you guys want to, I got another poster all about plate tectonics that can show why and how this all starts off. If you guys want me to, it's just in my office.
Well, we'd love to listen to that, but I think we're going to fill our Lego set here if you don't mind.
Alright, no problem, guys. Well, if you guys want to, you guys can keep this poster. I got multiple in my office. But I'm going to go off and I'm going to do some more research on volcanoes. But if you guys need any help, my office is just down the hallway, guys.
Okay, cool. Thank you.
No problem, guys.
Yeah, man.